Picture this. You're standing at the edge of the world's largest rainforest. The air is so thick with moisture, you can almost drink it. Somewhere in the distance, a jaguar moves silently through the shadows. Above you, trees stretch so high they seem to touch the clouds. And beneath your feet, an entire world you can't even see is working tirelessly to keep this planet alive. But here's what most people don't know. The Amazon isn't just some faraway jungle filled with exotic animals. It's actually the reason you're breathing right now. Every fifth breath you take comes from this forest. And if you think that's incredible, wait until you hear what's really going on here. Because today, we're going deep. We're talking about mysteries that scientists are still trying to solve. We're uncovering connections that link this forest to deserts thousands of miles away. And we're going to meet creatures so perfectly adapted to survival that they make evolution look like art. This isn't just another nature documentary. This is the story of how one forest keeps an entire planet alive. And by the end, you'll understand why what happens in the Amazon doesn't stay in the Amazon. It affects everyone, everywhere. If this story matters to you, hit like, so more people can discover these secrets. So buckle up. We're about to journey into the heart of Earth's last wild kingdom. Let's start with something that's going to blow your mind. The Amazon rainforest covers more than 2 million square miles. That's almost as big as the entire United States east of the Mississippi River. But size isn't even the most impressive part. See, most people think of the Amazon as just a really big forest. But that's like calling the ocean a really big puddle. The Amazon is actually a living, breathing machine. And once you understand how it works, you'll never look at forests the same way again. Here's the thing. Every year, the Amazon absorbs about 2 billion tons of carbon dioxide from the atmosphere. That's roughly the weight of 400 million elephants just disappearing into the trees. The forest then converts this carbon dioxide into oxygen, pumping it back into the air for the rest of us to breathe. But the Amazon doesn't do this alone. And this is where things get really interesting. Imagine you're a tree in the Amazon. You need nutrients to survive, right? But here's the problem. The soil beneath you is actually terrible. Most of the Amazon sits on ancient, nutrient-poor ground that should barely support any life at all. So, where do these nutrients come from? The answer is going to sound absolutely crazy. They come from Africa, specifically from the Sahara Desert, which is almost 5,000 miles away across the Atlantic Ocean. Every single year, winds sweep across the Sahara and pick up around 180 million tons of dust. This dust, then, travels across the entire Atlantic Ocean, riding on air currents like an invisible conveyor belt. And when it finally settles over the Amazon, it delivers something precious: phosphorus, the exact nutrient the rainforest desperately needs but can't produce on its own. Think about that for a second. A desert on one continent is feeding a rainforest on another continent. It's like the Earth has its own delivery system, and it's been running perfectly for thousands of years. Did you know about this Africa-Amazon connection? Most people are shocked, but the Amazon's relationship with the atmosphere doesn't stop there. In fact, this is where the forest really starts showing off its engineering skills. Now, you might think rain just happens, right? Clouds form, water falls, everyone gets wet. Simple. But in the Amazon, rain doesn't just happen. The forest actually creates it. Here's how. Every tree in the Amazon releases water into the air through tiny pores in its leaves. Scientists call this transpiration, but you can think of it as the tree breathing out moisture. Now, one tree doing this wouldn't make much difference. But when you have nearly 400 billion trees all releasing water at the same time, something incredible happens. The forest creates its own weather system. A single large tree can release more than 260 gallons of water into the atmosphere every single day. Multiply that by billions of trees, and you've got rivers in the sky. Actual rivers. Scientists call them flying rivers, and some of them carry more water than the Amazon River itself, which is already the largest river on Earth. These invisible rivers of moisture flow through the atmosphere, traveling thousands of miles. They bring rain to regions that would otherwise be deserts. They influence weather patterns across the entire continent. And they do all of this silently, invisibly, without anyone even noticing. But here's where it gets even stranger. Remember how we talked about the Amazon River being the largest river on Earth? Well, if you look at the forest from above, you'll notice something peculiar. The river branches out like veins, spreading water across thousands of miles. And up in the sky, the flying rivers follow almost identical paths. It's as if the Amazon has two circulatory systems, one flowing on the ground, one flowing through the air, both working together to keep the forest alive. And this dual system explains something that has puzzled scientists for years. How does the Amazon survive during dry seasons when rain sometimes doesn't fall for months? The answer is this invisible network, constantly redistributing moisture, feeding the forest even when the sky is clear. Subscribe if you want more mind-blowing science that changes how you see the world. With this incredible atmospheric machinery working overhead, let's drop down now and see what's happening on the ground, where the real drama of survival plays out every single day. Deep in the forest, where sunlight barely penetrates and shadows dance between the trees, there's a hunter, silent, powerful, almost invisible, the jaguar. Now, you might have heard of jaguars before. Big cat, spotted coat, pretty dangerous. But what you probably don't know is just how perfectly this animal is designed for killing. Because jaguars don't hunt like any other big cat on Earth. Lions hunt in packs, using teamwork to bring down prey. Tigers rely on speed and surprise, going for the throat. Leopards are ambush specialists, dropping from trees onto unsuspecting victims. But jaguars, they've developed something completely different. They have the strongest bite force of any big cat. Period. We're talking about 1,500 pounds per square inch of crushing pressure. That's enough to bite through a steel pipe. And they use this power in the most direct way possible. While other cats go for the throat or suffocate their prey, the jaguar goes straight for the skull. One bite, right through the bone. Instant kill. It's brutal, it's efficient, and it works on almost anything the forest has to offer. Deer? Easy. Wild pigs? No problem. Monkeys, birds, even massive reptiles with armor-plated skin. The jaguar handles them all. And here's the really impressive part. Unlike most cats, Jaguars are actually excellent swimmers. Picture this. You're a caiman, a reptilian predator, basically an alligator lounging in the river. You're at the top of the food chain in the water. Nothing messes with you. And then, out of nowhere, a jaguar explodes from the riverbank, latches onto your skull with those massive jaws, and drags you onto land. Game over. This ability to hunt both on land and in water makes the jaguar one of the most versatile predators in the world. And it needs to be, because the territory it controls is massive. A single jaguar can patrol an area of up to 100 square kilometers. That's about 38 square miles of rainforest that belongs to one animal. But there's something else about jaguars that makes them truly special. And it's something you can only see if you're extremely lucky. Every so often, a jaguar is born with a rare genetic condition called melanism. Instead of the normal golden coat with black rosettes, the entire animal is jet black. These are the legendary black panthers. Same species, same power, but wrapped in midnight. Black panthers move through the Amazon like ghosts. Indigenous people have told stories about them for generations, describing them as spirit guardians of the forest. And when you see one in person, even in photographs, you understand why. They seem to absorb light itself, becoming one with the shadows. Like this video if you want to see more apex predators in action. But as dominant as the jaguar is on land, there's another predator that rules a different realm entirely. One that doesn't need legs to be terrifying. In the slow-moving rivers and murky swamps of the Amazon, where visibility drops to zero just inches below the surface, something is waiting. Something that moves without making a sound. Something that can go months without eating. But when it strikes, almost nothing escapes. The anaconda. Now, most people have heard scary stories about anacondas. Giant snakes that swallow people whole, that kind of thing. And while those stories are mostly exaggerated, the reality of what anacondas can do is actually more impressive than any myth. Green anacondas are the heaviest snakes in the world. They can grow up to 30 feet long and weigh over 500 pounds. That's basically the weight of a fully grown lion, except it's all muscle, no bones, pure constricting power wrapped in scales. But size isn't what makes anacondas so successful. It's patience. An anaconda can stay perfectly still in the water for hours, sometimes days, barely breathing, barely moving, just waiting. Its eyes and nostrils sit on top of its head, so it can remain almost completely submerged while watching the world above. When prey comes to drink at the water's edge, maybe a capybara or a deer, the anaconda doesn't rush. It calculates. It waits for the exact right moment. And then it moves with shocking speed, grabbing the animal and dragging it underwater before it even knows what's happening. Here's where the killing method gets really fascinating. Anacondas don't crush their prey's bones like people think. That would be wasteful and take too much energy. Instead, they compress the victim's lungs. Every time the animal breathes out, the anaconda tightens its coils just a little bit more. The prey can't inhale. Within minutes, it's over. And then comes the really impressive part, swallowing. Anacondas can unhinge their jaws, but not in the way you might imagine. Their lower jaw is split into two separate pieces connected by elastic ligaments. This allows them to stretch their mouth around prey. That's significantly wider than their own head. They work slowly, methodically, pulling the victim deeper into their throat using backward-pointing teeth and muscular contractions. A large meal, maybe a 100-pound capybara, can take hours to swallow. And once it's down, the anaconda might not eat again for months. Its metabolism slows down to almost nothing, and it just sits there, digesting, waiting for the next opportunity. Share this with someone who's afraid of snakes. They need to see this. These underwater assassins share the rivers with another group of predators, though. Ones that hunt in packs and can strip flesh from bone in minutes. If you've ever watched a movie about the Amazon, you've probably seen the scene. Someone falls into the water, and within seconds, it's boiling with fish, blood everywhere, bones picked clean. It's dramatic, it's terrifying, and it's mostly nonsense. But that doesn't mean piranhas aren't dangerous, because they absolutely are, just not in the way movies portray them. Red piranhas are the most common species in the Amazon, and they travel in schools of 20 to 30 individuals. They have teeth like serrated razors, each one about 5 millimeters long, sharp enough to slice through muscle with a single bite. But here's what makes piranhas really effective. It's not just the teeth, it's the coordination. When a school of piranhas finds injured or dying prey, they don't attack randomly. They work together, each fish taking turns biting and tearing, creating a feeding rhythm that maximizes efficiency. A single bite might remove a chunk of flesh the size of a coin. But when 30 fish are all biting in rapid succession, they can cause a victim to lose more than a third of its body weight in minutes. Now, does this mean piranhas are constantly hunting large animals? No. Most of the time, they're actually pretty cautious. They prefer scavenging or eating smaller fish, insects, and even plants when necessary. They're opportunistic, adapting their diet to whatever's available. But during the dry season, when water levels drop and pools become crowded, competition increases. Food becomes scarce. And that's when piranhas become aggressive. That's when they start taking risks they normally wouldn't. Still, despite their reputation, piranhas aren't the apex predators of the Amazon's rivers. That title belongs to something much, much larger. Imagine a fish so old that its ancestors were around when dinosaurs walked the earth. A fish so large it looks like it belongs in the ocean, not a river. A fish that has to surface every 20 minutes, or it will literally drown. Meet the Arapaima, one of the world's largest freshwater fish and one of the Amazon's most bizarre success stories. Arapaimas can grow up to 10 feet long and weigh over 400 pounds. They're covered in thick, armored scales that feel more like medieval chainmail than fish skin. And they have a secret weapon that most fish don't. They can breathe air. See, the Amazon's rivers and swamps often have very low oxygen levels, especially during the dry season when water becomes stagnant. Most fish struggle in these conditions, but not the Arapaima. It evolved a specialized organ that works almost like a primitive lung, allowing it to gulp air from the surface. This adaptation means Arapaimas can survive in places where other large fish would suffocate. And it gives them a huge advantage when hunting. Arapaimas are ambush predators. They lurk in murky water, using their massive size and powerful bodies to create sudden bursts of speed. When they strike, they open their enormous mouths and create a vacuum, sucking in prey like a biological shop vac. Fish, amphibians, even birds that get too close to the surface. All fair game. But here's where things get interesting from a human perspective. Arapaimas have been hunted for generations by indigenous communities who value their meat and their massive scales, which can be used for tools and decoration. This hunting pressure pushed them to the brink of extinction in some areas. However, in recent years, something remarkable happened. Local communities started managing Arapaima populations sustainably, setting quotas, protecting breeding areas, and monitoring numbers carefully. The result? Arapaima populations have started recovering, and it's become a model for how traditional knowledge and modern conservation can work together. This is conservation done right. Subscribe to see more success stories. But while these giants dominate the rivers, there's an entirely different world unfolding high above the water, in the forest canopy where life moves at a very different pace. "90% of its life hanging upside down, moving at a speed so slow you could outpace it by walking casually, eating leaves that provide almost no nutrition. This is the sloth, and it might just be the strangest survival strategy in the entire Amazon. Sloths live in the canopy layer, about 100 to 150 feet above the ground, and they've made peace with being incredibly, almost absurdly slow. We're talking 0.24 kilometers per hour. That's about the speed of a snail having a leisurely stroll. But this isn't laziness, it's genius. See, the leaves sloths eat are incredibly low in calories and nutrients. A sloth's entire digestive system is optimized for efficiency, not speed. A single meal can take up to 30 days to fully digest. 30 days. And because their metabolism is so slow, they only consume about 160 calories per day. That's less than a single candy bar. This slow lifestyle means sloths don't need to move much. And not moving has a massive advantage in the rainforest. It makes you invisible to predators. Jaguars, harpy eagles, and other hunters rely heavily on movement to spot prey. A sloth hanging motionless in the trees, covered in algae that turns its fur green, blends perfectly with the foliage. Predators look right past it. But the sloth's fur isn't just camouflage. It's actually an entire ecosystem. Moths, beetles, algae, even fungi live in a sloth's coat. And when the sloth grooms itself, it accidentally ingests some of this algae, which provides extra nutrients. It's a mobile microenvironment, a garden growing on an animal's back. There's one more bizarre thing about sloths that nobody talks about. Once a week, a sloth will slowly climb down from the canopy, dig a small hole at the base of the tree, and defecate. Then it climbs back up. This trip takes hours and exposes the sloth to massive danger. So why do it? Scientists believe it's about fertilizing the tree. By depositing waste at the base, sloths help nourish the very trees they depend on. It's a partnership between animal and plant that's been going on for millions of years. While sloths master the art of stillness, there are other canopy dwellers who've perfected something completely different: speed, noise, and social chaos. Just before dawn, when the Amazon is still wrapped in darkness, a sound erupts. It's deep, guttural, almost prehistoric. It carries for miles, echoing through the trees like a warning from another time. This is the howler monkey, and it has the loudest call of any land animal in the Americas. Howler monkeys can project their voices up to 3 miles through dense forest. That's not exaggeration. 3 miles. They achieve this through a specialized larynx that's basically a built-in amplifier. And they use this voice for one primary purpose: marking territory. When a troop of howlers wakes up, they announce their presence to every other troop in the area. It's a vocal fence, a way of saying, "This section of forest is ours. Stay away." This system prevents conflicts, reduces energy wasted on fighting, and keeps different groups from running into each other. But howlers aren't just about noise. They play a crucial role in seed dispersal. They eat fruits, travel long distances, and then deposit seeds far from the parent tree. Some plants in the Amazon depend almost entirely on howler monkeys for reproduction. Now, sharing the canopy with these vocal giants are the acrobats of the rainforest, spider monkeys. If howler monkeys are the announcers, spider monkeys are the athletes. They move through the trees with such grace and speed that watching them feels like watching a high-wire act at a circus. Except there's no net, and they're doing it 150 feet in the air. Spider monkeys have incredibly long limbs and a prehensile tail that works like a fifth hand. This tail is so strong they can hang entirely from it while using all 4 limbs to grab food. And they need this level of agility because they travel huge distances every day searching for ripe fruit. Unlike howlers, who eat mostly leaves, spider monkeys are fruit specialists. They have an incredible memory for which trees produce fruit and when. Scientists have observed spider monkeys traveling miles to visit a specific tree on the exact day its fruit ripens. That's some serious planning. These monkeys can also swing from branch to branch at speeds up to 15 miles per hour. They leap gaps that would terrify most animals, trusting their reflexes and grip strength completely. And when they move in groups, it looks like the forest itself is flowing. Comment: which Amazon animal amazes you most? Let us know. But while these primates dominate the day shift, when the sun sets, an entirely different hunter takes over the canopy. Night falls over the Amazon, and the forest transforms. What was loud becomes quiet. What was visible becomes hidden. And in this darkness, one predator is just waking up. The great horned owl, with a wingspan stretching up to 5 feet and talons that can generate 300 pounds of crushing force. This bird is an apex predator of the night sky. But its true power isn't size or strength, it's perception. An owl's eyes are enormous relative to its body, accounting for almost 5% of its total weight. These eyes are specially designed to gather light, allowing the owl to see in near total darkness. But vision is only part of the equation. The real magic happens with hearing. Owl ears are positioned asymmetrically on their heads. One ear is slightly higher than the other. This tiny difference allows the owl to triangulate sound with ridiculous precision. When a mouse rustles leaves below, the owl can pinpoint its exact location based on sounds reaching each ear just millionths of a second apart. It's like having a 3-dimensional sound map of the entire forest. And then there's the silent flight. Owl feathers have specialized edges that break up air turbulence and muffle sound. When an owl flies, it makes almost no noise. The prey has no warning, No whoosh of wings, no shadow, nothing. Just talons appearing out of darkness. This combination of silent flight, incredible hearing, and night vision makes the great horned owl one of the most effective hunters in the Amazon. It controls rodent populations, hunts snakes, and even takes down other birds. But as dawn approaches and the owl returns to its roost, the forest begins to wake again. And with the light comes color, so much color that it almost doesn't seem real. If the Amazon had a mascot, it would probably be the macaw. These birds are so visually stunning, so impossibly colorful, that seeing one in person feels like watching a painting come to life. Scarlet macaws, blue and gold macaws, green-winged macaws. They're not just beautiful, they're loud, intelligent, and absolutely essential to the forest's survival. Macaws mate for life, forming bonds that can last decades. When you see two macaws flying together, wingtips almost touching, synchronized perfectly, there's a good chance they've been partners for years. They communicate constantly, using calls that carry for miles, warning each other of danger or coordinating where to feed. But here's where macaws become really important to the ecosystem. They're seed dispersers, and not just any seeds. Many Amazonian trees have fruits with extremely hard shells that most animals can't crack. Macaw beaks, though. They generate enough force to crush a Brazil nut, which requires over 300 pounds of pressure. After eating the fruit, macaws fly long distances before the seeds pass through their digestive system. This means they plant trees far from the parent, preventing overcrowding and spreading genetic diversity throughout the forest. There's one behavior that macaws do, which looks completely bizarre until you understand the science behind it. Clay licks. Along certain riverbanks, exposed clay walls become gathering points for dozens, sometimes hundreds of macaws. They land on these walls and literally eat clay, just pure clay. Why? Because many of the seeds and fruits they consume contain toxins. The clay binds to these toxins, neutralizing them and preventing the birds from getting sick. It's like a natural pharmacy. The macaws have figured out that this specific type of clay acts as medicine, and they pass this knowledge down through generations. Scientists study these clay licks intensely because they reveal how animals self-medicate, how they choose specific minerals, and how social behavior influences individual choices. But as vibrant as these birds are, there's another creature in the canopy that might be even more remarkable. One that doesn't need a beak to hunt. It needs silk. Spiders in the Amazon have taken engineering to an art form. And nowhere is this more obvious than with the orb weaver spider, which constructs webs so strong that, pound for pound, their silk is tougher than steel. Think about that. A tiny spider produces a material that outperforms one of humanity's strongest inventions. And it does this naturally, every single day, without tools or blueprints. These webs can span several feet and are designed with mathematical precision. The radial threads provide structure, while the spiral threads, coated in sticky droplets, trap prey. When an insect flies into the web, vibrations travel along the threads instantly, alerting the spider to the exact location of its victim. Some orb weavers have a hunting success rate of 50%. That's phenomenally high. And they achieve this by constantly adjusting their webs, repairing damage, and even rebuilding entirely based on what they catch. But not all spiders use webs. The Goliath bird-eater, the world's largest tarantula, doesn't bother with silk traps. It's an ambush predator, relying on stealth and sheer size. With a leg span reaching up to a foot and fangs nearly an inch long, the Goliath bird-eater hunts by sensing vibrations through its burrow. When prey walks nearby, the spider bursts out with shocking speed, sinking its fangs in and injecting venom that quickly immobilizes the victim. Then comes the gruesome part. The spider secretes digestive enzymes that liquefy the prey's insides, turning it into a nutrient-rich soup that the spider can consume. It's brutal, but in the Amazon, efficiency matters more than elegance. And speaking of efficiency, there's an entire civilization operating beneath the forest floor that makes even the most organized human cities look chaotic by comparison. You'd never notice them unless you looked carefully. But beneath almost every section of Amazonian forest, there's an empire, an underground network of chambers, highways, and farms run by some of the planet's most sophisticated insects, leafcutter ants. These ants don't eat the leaves they cut. Instead, they carry them back to their nests and use them to grow fungus. That's right, they're farmers. And they've been doing this for millions of years, long before humans figured out agriculture. A single colony can contain up to 8 million ants, all organized into a strict caste system. There are tiny ants that tend the fungus gardens, medium-sized ants that cut and transport leaves, and massive soldier ants with jaws so powerful they can draw blood from human skin. The entire operation runs with military precision. Scout ants find suitable leaves. They mark trails with pheromones. Worker ants follow these chemical highways, cut leaf fragments up to 50 times their own weight, and carry them back in endless lines. But here's the really clever part. The ants don't just dump leaves into the fungus garden. They chew them into a pulp first, essentially creating compost. Then they add their own fecal matter, which contains enzymes that help break down the plant material. The fungus grows on this mixture, and the ants harvest it as food. And they keep this system sterile. If a harmful bacteria or competing fungus tries to invade, the ants have a built-in defense. They carry antibiotic-producing bacteria on their bodies that kill intruders. It's a three-way partnership: ants, fungus, and bacteria, all working together. These colonies can extend over 250 square feet underground, with thousands of chambers dedicated to different tasks. It's the insect equivalent of a city, and it's completely hidden from view. Share this with a science teacher. Students need to see nature's genius. But while these farmers work in darkness, there's another layer of life thriving in the spaces between trees and ground, a world of vibrant, deadly beauty. The forest floor of the Amazon is damp, shadowy, and covered in a thick layer of decaying leaves. It seems quiet, peaceful even. But hidden among this debris is one of the most toxic creatures on Earth, the poison dart frog. These frogs are tiny, often no bigger than a paperclip, but their skin secretes some of the most potent toxins known to science. We're talking about batrachotoxin, a compound so deadly that a single frog carries enough poison to kill 10 grown humans. And they advertise this fact with their colors: bright blues, vivid yellows, electric oranges, and deep reds. In nature, these colors are a warning. They tell predators, if you eat me, you will die. But here's something fascinating. Poison dart frogs raised in captivity aren't poisonous. The toxins don't come from their bodies, they come from their diet, specifically from the ants, termites, and mites they eat in the wild. These insects contain alkaloids, and the frogs concentrate these chemicals in their skin. So the frogs aren't producing poison, they're recycling it from their environment, transforming food into a chemical weapon. Indigenous people in some parts of South America figured this out centuries ago. They would capture these frogs, carefully extract the toxin, and apply it to the tips of blow dart arrows. Hence the name poison dart frog. But despite being so toxic, these frogs have predators. One species of snake has evolved resistance to the poison and actively hunts them. It's an evolutionary arms race, toxin versus resistance, playing out on the forest floor. And while these tiny amphibians have mastered chemical warfare, there's a much larger creature that's perfected an entirely different survival strategy: blending in. In a forest filled with predators, one animal has survived by being the exact opposite of aggressive. It doesn't fight. It doesn't run fast. It just exists peacefully in massive social groups. The capybara. Capybaras are the largest rodents on Earth, weighing up to 140 pounds. They look like oversized guinea pigs with blunt snouts, webbed feet, and a calm, almost meditative presence. They live along riverbanks, spending much of their time in the water to stay cool and avoid predators. Their eyes, ears, and nostrils are positioned high on their heads, allowing them to stay mostly submerged while still being aware of their surroundings. When danger approaches, maybe a jaguar or an anaconda, capybaras don't panic. They calmly slide into the water, sometimes diving completely to hide beneath the surface. They can hold their breath for up to 5 minutes, waiting for the threat to pass. But their real survival strategy is numbers. Capybaras live in groups of 10 to 30 individuals, sometimes even more during the dry season when water sources shrink. These groups have sentinels, individuals who stay alert while others feed or rest. If one spots danger, it vocalizes, and the entire group reacts instantly. They're also surprisingly tolerant of other species. Birds perch on their backs to hunt insects. Turtles bask next to them in the sun. Even caimans, which are technically predators, often ignore adult capybaras because they're simply too large and alert to be easy targets. And here's something that surprises most people. Capybaras are highly social and affectionate. They groom each other, vocalize constantly, and form strong family bonds. Watching a group of capybaras interact feels less like observing wild animals and more like watching a tight-knit community. They're proof that in the Amazon, survival isn't always about being the strongest or fastest. Sometimes it's about cooperation, awareness, and knowing when to simply let things be. But as peaceful as capybara life seems, they share their world with a creature that operates on an entirely different frequency, one that sees with sound. In the murky, tannin-stained waters of the Amazon River, where visibility is measured in inches rather than feet, there's a creature that seems like it shouldn't exist. A freshwater dolphin, bright pink, almost mythical. The Amazon river dolphin, or boto, is one of the strangest and most adapted aquatic mammals on the planet. Unlike ocean dolphins, botos have incredibly flexible necks. They can turn their heads 90 degrees, allowing them to navigate through submerged tree roots and flooded forests during the rainy season. Their flippers are large and paddle-like, perfect for maneuvering in tight spaces. But the most remarkable feature is how they hunt. Botos use echolocation, emitting clicking sounds that bounce off objects and return as echoes. These echoes create a three-dimensional sound map of their surroundings, allowing them to see in complete darkness. A fish hiding under a log? The Boto knows. A school of prey changing direction? Detected instantly. Even prey buried in mud can't hide from this biological sonar. And their pink color. Scientists believe it comes from blood vessels close to the skin surface, combined with scarring from fights and interactions with other dolphins. Older males tend to be the pinkest, their color a testament to years of survival. In local folklore, Botos are considered magical. Some stories say they can transform into humans at night, appearing on riverbanks before disappearing at dawn. These legends reflect deep respect for a creature that seems to exist between two worlds, water and land, reality and myth. But Botos face serious threats. Fishing nets, boat traffic and pollution have caused population declines in some areas. And unlike ocean dolphins, which have vast ranges, river dolphins are confined to specific waterways, making them especially vulnerable to environmental changes. Still, they persist. Silent, pink, almost ghostly, navigating a world humans can barely perceive. And as we rise from these mysterious waters and look toward the horizon, we need to confront a difficult truth about what's happening to this entire ecosystem. Everything we've talked about so far, every predator, every adaptation, every interconnected relationship exists within a forest that's now facing the greatest threat in its history: humans. Let's be clear about the numbers, because they're staggering. In the last 50 years, approximately 17 to 18% of the Amazon rainforest has been destroyed. That's an area larger than the entire country of France, just gone. And we're approaching what scientists call the point of no return, the threshold where the forest can no longer sustain itself. If we lose another 3 to 5%, the Amazon might shift from rainforest to savanna, a dry, open ecosystem incapable of supporting the biodiversity we've explored. The main driver? Deforestation. Trees are cut down for cattle ranching, soy farming, logging and mining. Roads slice through once untouched areas, opening the forest to further exploitation. But deforestation doesn't just destroy habitats, it disrupts the entire water cycle. Remember those flying rivers we talked about earlier? When you remove trees, you remove the system that generates rain. Less rain means more drought. More drought means more fires. More fires mean even more forest loss. It's a feedback loop. And it's accelerating. Climate change is making this worse. Rising temperatures and changing rainfall patterns are pushing the Amazon into territory it's never experienced before. Wildfires, once extremely rare in this wet environment, are becoming common. Entire regions that should never burn are going up in flames. And the consequences aren't limited to South America. The Amazon stores between 90 and 140 billion tons of carbon. If this forest collapses, all that carbon gets released into the atmosphere, accelerating global warming and impacting weather patterns worldwide. Indigenous communities who have lived in the Amazon for thousands of years manage their territories with remarkable success. Areas under indigenous control have significantly lower deforestation rates than unprotected regions. These communities understand the forest in ways that modern science is only beginning to appreciate. Conservation programs are also making a difference. Reforestation projects, sustainable management practices, and protected reserves are helping damaged areas recover. Scientists are discovering new species every year, reminding us how much we still have to learn. And individuals can contribute too. Supporting conservation organizations, making sustainable choices, and advocating for stronger environmental policies all create ripple effects. Because the Amazon isn't just a forest in South America, it's a critical component of Earth's life support system. And protecting it is protecting ourselves. So here we are at the end of our journey through the Amazon. We've met jaguars that hunt with bone-crushing power, anacondas that move like liquid shadows, sloths that survive by doing almost nothing, and dolphins that see the world through sound. We've explored a forest that creates its own rain, receives nutrients from a desert thousands of miles away, and supports more life in a single square mile than some countries have in their entirety. But more than anything, I hope you've come to understand this. The Amazon isn't just a place. It's a living system, a network of relationships so complex and interconnected that we're still discovering how it all works. And it's worth saving, not just because it's beautiful, though it is. Not just because it's full of incredible creatures, though it is that too. But because the Amazon is proof that life, when given the chance, creates something extraordinary. Every breath you take is connected to this forest. Every weather pattern, every rain shower, every ecosystem on this planet is influenced by what happens here. The Amazon is Earth's last wild kingdom, a place where nature still operates on its own terms, where survival is an art form, and where evolution has crafted solutions more elegant than anything humans could design. And that's a legacy worth fighting for. Thanks for joining us on this journey. If you found this story powerful, share it. Talk about it. Because the more people understand what's at stake, the better chance we have of keeping this incredible world alive for future generations. The Amazon is calling. Let's make